Hello, today I'll be going over the second half of A.3, which is factoring. So for the non-special cases, you can use the x method to factor. So in order to use the x method, first you want to make sure the equation is in standard form. So it's in the form ax squared plus bx plus c, and you want to factor out any GCF before you start with the x method. So for the x method, you'll have this x. On the top is a times c, so the a value from standard form and the c value from standard form, and on the bottom is b. You'll want to find two numbers that multiply to a times c and add to b. So for example, if we have x squared plus 3x plus 2, we can use the x method. On the top is a c, so here a is 1, b is 3, and c is 2. So a times c is going to be 2. And on the bottom we have the b value, which is 3. So we want to find two numbers that multiply to 2 and add to 3, and that will be 1 and 2. And on top of these numbers, we're going to write x, since x times x will equal x squared. So these two are going to be the factors. So this is x plus 1 times x plus 2. And if we multiply that out, you'll get the original problem, which was x squared plus 3x plus 2. If a is not 1, the beginning process is the same, but there is one little difference. So for example, if we have 2x squared plus 5x plus 2, a is 2, b is 5, and c is 2. So the top is still a times c, which is going to be 4, since 2 times 2 is 4. And on the bottom is still the b value, which is 5. And the two numbers that will multiply to 4 and add to 5 are 4 and 1. And this time the difference is, since a is not 1, we're going to write 2x on the top and on the bottom. And now we have like these fractions, and we can see if we can simplify. So on the left one we can divide both by 2, so we get x over 2. And on the right we cannot simplify. So the two factors would be x plus 2 times 2x plus 1. Okay, next we have factor by grouping. So this is the method that you'll use when there are 4 terms. You want to rewrite in standard form if necessary, factor out the GCF if possible, group the first 2 terms and factor out the GCF, and then repeat for the second group of terms, and then factor the GCF and factor again if possible. So there's a lot of factoring involved. So here's the first example. This is in standard form, so I don't have to rewrite it. And the GCF is 2, because I can factor out a 2 from everything. So next, I'm going to group the first 2 together and the second 2 together. So in the first 2 terms, x cubed plus 5x squared, the GCF from that is going to be x squared. So that means I have x plus 5 left. So this was the pink part from above. Then from negative 9x minus 45, I can factor out a negative 9. So I'm left with x plus 5. Okay, and they both have x plus 5. So we can factor that out. So we have that 2 that we factored out in the beginning and x plus 5. And if we take that away from the first part in pink, then we're left with x squared. And if we take out a x plus 5 from the second part in purple, we have minus 9. So in some problems you will stop here, but in this case, x squared minus 9 is difference of 2 squares, so we can factor even more. So that will factor into x plus 3 times x minus 3. So this here is the final answer. Okay, so here are some examples we'll want to factor. We want to find the GCF such that the remaining factors have only integer coefficients. So that means if there are any fractions, we want to take that out. So we do have a fraction, we have 1/3. So we want to factor out 1/3. And looking at the variables, we can factor out a y. So if we factor 1/3 y from 1/3 y to the 4th, we're left with y cubed. And then for the second term, you want to think about what number times 1/3 will equal -5. So since we factored out 1/3, we want to be able to distribute 1/3 y to everything and get the original problem back. So 1/3 times -15y will equal -5y squared. So that's why this number is 15 here. And if we factor out 1/3 y from 2y, we would be left with 6, because 6 times 1/3 y will equal 2y. And we can't combine anything, so this is the final answer. Number 10. So first we want to rewrite this in standard form. And factor out the negative in front of x squared. So we always want a to be positive. Okay, so next we can use the x method. On the top is going to be -24 since a is 1 and c is -24, and on the bottom is -5. So the two numbers that multiply to -24 and add to -5 are -8 and 3. And on the top is going to be x. So we still have that negative that we factored out earlier, and we have x minus 8 and x plus 3. So those will be the two factors. Okay, number 11. This is actually a difference of two squares. So this is in the form a squared minus b squared, which is going to factor into a plus b times a minus b. So in this case, a squared is 25 and b squared is x plus 5 squared. So that means a is going to equal 5 and b is going to equal x plus 5. So now that we found a and b, we can plug it into the equation. So that would be 5 plus x plus 5 times 5 minus x plus 5. 5 plus x plus 5 is going to be x plus 10. And we're going to distribute the negative, so we get 5 minus x minus 5, which will simplify to -x. So this would be the final answer. Okay, number 12. We first want to factor out the GCF, which is going to be 9 for this problem. So we're left with 4x squared minus 12x plus 9. And there's two different ways to do it from here. Either you recognize that it's a perfect square trinomial, or you can use the x method. So I'll show you both. For the x method, a is 4 and c is 9, so this is going to be 36. And on the bottom will be the b value, which is -12. So the two numbers that multiply to 36 and add to -12 are -6 and -6. We have 4x on top, since a is 4x. And both of these we can simplify to 2x over -3. So you can write this as 9 times 2x minus 3 squared, or 9 times 2x minus 3 times 2x minus 3. Okay, and the other method, if you recognize that this was a perfect square trinomial, we know that a squared is going to equal 4x squared, and b squared is going to equal 9. So that means a is 2x, and b is 3. So we have the 9 that we factored out, and since this was a minus sign, we're going to have a minus, oops, sorry. We're going to have a minus sign in the middle, so 2x minus 3 squared. Okay, next problem. We first want to rewrite this into standard form, so that'll be negative x to the 4th minus 3x cubed plus 2x plus 6. And since there are 4 terms, we want to factor by grouping. So in the first two, we can factor out negative x to the 3rd. So we're left with x plus 3. And in the second two, we can factor out a 2. So we're left with x plus 3. So both of these terms have an x plus 3, so that means we can factor that out. And then we have negative x cubed plus 2 left. And to factor out the negative in front of the x cubed, we can take out a negative from that part of the problem. And that means we're left with x cubed minus 2. So if it helps, I'll write it under here. So this I factored out as x cubed minus 2, and since everything is being multiplied, I don't want the negative in the middle, otherwise it looks like a subtraction, so that's why I moved it to the front. So I moved this negative sign to the front here. And we can't factor anymore, so that's the final answer. Okay, number 14. So we first want to rewrite this into standard form. So we have 8x to the 5th plus 12x cubed minus 6x squared minus 9. And since we have 4 terms, we want to factor by grouping. So we're going to group the first two and the last two. In the first two, we can factor out 4x cubed, and we'll be left with 2x squared plus 3. In the second group, we can factor out negative 3, and we're left with 2x squared plus 3. And now they both have 2x squared plus 3. So we can factor that out, and we'll be left with 4x cubed minus 3. And we can't factor anymore, so that would be the final answer. Okay, next section. Here we have a really long equation. So we want to see what they both have. They both have x plus 1. And the second term has x plus 1 squared. So we always want to factor out the smaller one. So we'll factor out x plus 1. And there's also x minus 3. So in the first term, it's x minus 3 squared, but in the second term, it's only x minus 3, so we can only factor out x minus 3. And then looking at the numbers, we can't factor anything from 2 and negative 3, so we can leave those alone. So if we factor out x plus 1 times x minus 3 from the first term, the x minus 1 kind of gets canceled out since it was factored out. So we're left with 2. And we took away 1 of the x minus 3's, so there's only 1 left. Then for the second term, we factored out 1 of the x plus 1's, so there's 1 left. And we canceled out the x minus 3, or we factored out the x minus 3. So we have minus 3 times x minus 3. So now we want to just simplify the long equation, or the part in the parentheses, the second part. So that's 2x minus 6 minus 3x plus 9. So that's going to be negative x plus 3. And again, to factor out that negative in front of x, we can take that out, or factor out a negative, and rewrite it as x minus 3. So this would be negative x plus 1, x minus 3, times x minus 3, or negative x plus 1 times x minus 3 squared. Okay, number 16. We can look for factors from here, or you can first simplify the terms a little bit. So if we look at the first term here, we can multiply some numbers and x's together. So this will be 6x to the fourth. So I'm combining the 3 and the 2x and the x cubed. That'll become 6x to the fourth. And we have x squared plus 1 squared. And in the second part, we don't have any terms that we can multiply or simplify, so I'll just leave it as 3x squared times x squared plus 1 cubed. Okay, so now we're looking for things that can factor out from both. So there's a 6 and a 3, so we can factor out a 3. There is a x to the fourth and x squared. So the most x's that we can take out is x squared. And there's also x squared plus 1 squared and x squared plus 3 cubed. So that means we can factor out x squared plus 1 squared. Now if we factor this out from the first term, so this term right here, that means we'll be left with 2x squared, since 2 times 3 is 6, and x squared times x squared will be x to the fourth. And the x squared plus 1 squared is already factored out, so we don't have any more of those in the first term. And in the second term here, we factored out the 3 and the x squared, so there's none of those left. But we do have 1 x squared plus 1 left, since there were 3 of them, but we took out 2. Okay, so now we're just going to simplify the parentheses. So 2x squared plus x squared plus 1 is 3x squared plus 1. And we can't factor anymore, so this would be the final answer.